Hello, Mr. Peters Calculus class. This is PHS alumni Blake Wilson, and I will be teaching you all about optimization. So, what is optimization? Optimization is finding the maximum or minimum relationship between two equations. This usually comes in the form of a word problem. It's going to be something like, you're given 500 feet for a perimeter, and you have to find the maximum area of that perimeter. So it'll usually be fencing or something like that. This will be the first problem that we do since it's a very simple one. And because we're finding a maximum or minimum, we have to find some sort of derivative. To start off with, we're going to use two simple equations to describe this box. The first one is going to be the perimeter. So the perimeter is equal to 2x plus 2y. Now, this is simple just because you could do that yourself. Just by adding both sides of y and both sides of x, you can easily get the perimeter. Now the area, as you know, is just x times y. So, because of that, how do we get both of these into one equation, and then how do we get the maximum area out of that? Alright, so here's what we do. We set the perimeter equal to 2x plus 2y, and then we set the area equal to x times y. Now the perimeter, as we were given earlier, is actually equal to 500. So we have 2x plus 2y equals 500. Now, we have to set this up so that way the perimeter and area are related. And since we're given two variables, we have to get rid of one. So what we do is, we take the constraint, which is going to be whatever you're given. So we were given the perimeter, and we have to use that perimeter to find the maximum area. So we have 500 equals 2x plus 2y. Now, we're going to try to isolate one variable. In this case, we're going to isolate x. So we're going to bring the 2y over to the 500. So 500 minus 2y equals 2x. And then we're going to simplify. So 250 minus y equals x. Now we're going to plug the 250 minus y equals x for the x in area. Now this does two things. One, it eliminates one variable, it eliminates x. And two, it puts the two equations into one equation. So now we have the area in terms of the perimeter. So we simplify that even more, and we get 250y minus y squared. And then we take the derivative of that, so it's 250 minus 2y. Since we're looking for a maximum, we set the derivative equal to 0. So 250 minus 2y. And then we solve for y. Bringing the 250 over, y now equals 125. Now, this is very important to remember because where y is equal to 125, that is where the derivative is equal to 0, and that is where we have a maximum. And this maximum is the relationship between area and perimeter of the shape, because we have set the relationship earlier. So now we plug y back in. So because we got 125, we plug y back into the original equation for perimeter, and we solve for x. So we have 250 plus 2x equals 500, and then we bring the 250 over, so it's 2x equals 250, and now x equals 125. So the maximum area, if we plug both x and y in, is going to be 125 squared. This is the maximum area.